What is background? My name is Tatsuya Sagawa. I'm an undergraduate student at Kyoto University, and I major in pharmaceutical science. I'm working as an intern at Risto Inc. and Iris Inc. I previously participated in various Kaggle competitions and won medals, but this competition was my first ASR competition, so it is very difficult, but I learned a lot. This is motto.
I think.
Sorry, we cannot hear you. Moto-san.
I forgot to cancel the mute. So sorry. My name is Moto. I'm undergraduate student of science faculty at Kyoto University. I'm learning mathematics and physics at university. I often participate Kaggle competitions in vacations. It's my first ASL competition. Yes, it was my first ASL competition.
Suprabhat, Japana ekan shakar naita. Oh, what I just said is, good morning. Japan is now 9 a.m. in Bengali. Please use the current audio as a data set of dialectal accents. My account name is Esprit. I work as a data scientist at KDDI Corporation. I work on machine learning engineering on a daily basis, with particular expertise in NLP. I also specialize in NLP competitions as well as Kaggle competitions. I love Kaggle.
This is the overview of our training pipeline, and it mostly consists of 3 parts. First, train CTC model, train LM, and train punctuation model. First is train CTC model. We trained CTC model with part of the competition data, and using that trained data, we made predictions against all competition data. And then we conducted the data filtering and deleted the data with their water error rate is over 0.75. Then created the cleaned competition data set. Using this cleaned competition data, we retrained the CTC model and created to final our CTC model. Next is trained language model. We trained 5-gram language model using KLM and large text data. Concatenating this CTC model and 5-gram LM, we created ASR model and used this for our inference phase. The target transcription included many punctuations, but those punctuations mostly don't have any sounds, so ASR model couldn't predict them. So we also created the punctuation models to restore punctuations from ASR model's prediction. Based on XLM robot large and XLM robot base, we fine-tuned them with large text data and created the punctuation models. Taking their predictions, taking weighted average of their predictions, we made ensemble punctuation model, and we use this model for inference phase. Except please. This is the detail of our CTC model training. We use the Indic Web to VEC V1 Bengali as a backbone. As a training data, we use the cleaned competition data. As a note, the competition ASR data was very noisy, and training a CTC model with all of it deteriorated its performance. So first, we trained the CTC model with part of competition data and conducted data cleaning using the trained model. With this clean data, we retrained the CTC model. As shown in the right below figure, training with all competition data deteriorated its performance. However, after training competition data and the fine-tuning with that data, model's performance improved a lot. Next is language model. We used the word level 5-gram language model based on KNLM. And used training data is competition data in the COP-V2, Common Voice, Flavors, OpenSLR 53, OpenSLR 37, and Oscar. As a note, there was a large domain shift between train and test data, and there were auto vocabularies that appear only in test data. So we included various external text data into language model training data and trained to decrease out of vocabulary.
We have created the model that predicts punctuations that will go between each word in a sentence. As shown in the figure on the upper right, the model predicts whether a space, comma, lambda, question mark, or hyphen will be placed between each word. Next is summary of training the model. Trainer was XLM Roberta for token classification. Backbone was XLM Roberta, base, and large. Dataset was competition data and public dataset in the COP-V2. Punctuations are space, comma, lambda, question mark, and hyphen. Since all of these characters are found in many given sentences, we decided to predict them. Next slide, please. GPU I used was Think RTX 4090. Train time was 46 hours per epoch. We applied this punctuation model to predictions in the CTCLM. The score improvement is described. Initially, improvements were seen using public models. However, there was room for improvement due to the small backbone and lack of training data. So we decided to train the model ourselves. As a result, the score improved significantly. Next slide, please.
I will talk about the inference phase. The inference phase consists of deciding whether to apply denoise phase and predicting actual target phase. The predicting actual target phase is very simple, only predicting with CTCLM and add punctuation with ensembled punctuation model. I will talk about the decide whether to apply denoise phase. First, we denoise the test data and made denoise test data and predicted with denoise dataset and not denoise dataset. We compared the length of the prediction with denoise dataset and not that of not denoise dataset. If the length of the prediction with denoise dataset is shorter than that of not denoise dataset, we categorize the data as potential ID test, and otherwise, we categorize it as potential OOD test. If the data is categorized as OOD tested data, we made predictions with denoise dataset. But if the data is categorized as ID test, we made a prediction with the original audio data. I will talk about the detail of the denoise thing. We denoise test data using DMAX, a music separation model. It improved the LB score 0.002. However, Demux makes the CV score 0.009 worse. So we decided to conduct filtering. The filtering process is as follows. Compare the length of the prediction. If the length gets shorter when we make predictions by the denoised data, we judge that Dmax made the audio worse and predicted with original audio. This filtering improved the LV score 0.001. The right graph shows that if the prediction with the denoised dataset is shorter than that of not needed dataset, the performance tend to be worse. The red circle. This denoised thing phase finally improved a private leaderboard score 0.01. The reason will be the existence of noises and BGMs. This is the end of the presentation. Do you have any question?